In this video, we're going to have a look at graphing cubics when they're in inflection form. And inflection form really looks like this form down here. If you have a look at it, it really looks very similar to the turning form, or the turning point form from quadratics, except it's cubed instead of squared. And so what we're going to do is we're going to build up to that. Now, if we have a look at this first example here, we've got y equals x cubed, our y-intercepts and our x-intercepts. Remember, to try and find where it crosses the y-axis, what we're going to do is we're going to make x 0. So if I'm trying to find my y-intercept, I say y, what is y going to equal when x is nothing? So y is going to equal nothing. So when x is nothing, y is nothing. When we go to find out our x-intercept, I'll do the opposite. I will say, if I make y nothing, what will x be? To get rid of that cubed, I just do the cubic root of both sides. And of course, the cubic root of 0 is nothing. So x is nothing. So when x is nothing, y is nothing. The dominant term is taken from here. In this case, it's going to be x cubed. And if it was 2x cubed, it would be 2x cubed. Okay. And the point of inflection is also going to be our y-intercept in this case, which is 0, 0. And we'll elaborate on that a little bit more later. So it looks like the line's just going to pass through 0, 0 here. It's also the point of inflection, and so the curve will look like this. In the second example, the difference is there's a constant of -8. And we know from linear and quadratics that that means that our y-intercept is going to be at 0, -8. But so that we're not being lazy here, we'll do it properly. We'll say, if we're working out our y-intercept, what's y going to be when x is 0? Y is going to be -8. So our y-intercept will occur when x is 0, y will be -8. Similarly, if I'm trying to find my x-intercept, what I'm going to do is make y nothing. So to find the x-intercept, if y is nothing, find x. Let's add 8 to both sides. So we've got 8 equals x cubed. Let's do the cubic root. Oops, a daisy. I'm going to do the cubic root of 3. I'm going to do the cubic root of both sides. So x will be 2. So we've got our x-intercept. And our point of inflection, again this time, is going to be the same as our y-intercept, 0, -8. So we know that it will pass through here, -8, and it will complete the curve across the x-axis at 2. So this one will curve like this, parallel to the other one. That wasn't a very good drawing. Still not a very good drawing. Let's move on. In the second examples, we've got them actually here in a format that's far more familiar to us. This does look like the turning point form, doesn't it? So here I can start with the point of inflection, and I can see that that is going to be at -1, +64. And I'm getting that from here, same as what we did, this value here and this value. So we know that here at -1, 64 is going to be our point of inflection. So it's going to look something like this when we graph it. We don't know our y-intercept yet, so We do that by making x 0. So if we're working out our y-intercept, say, what's y going to be if we make x 0? 0 plus 1 cubed plus 64. So y will be 0 plus 1 is 1, 1 cubed plus 64. 1 cubed is 1, so y is going to be 65. So we've got our y-intercept. X is 0, y is 65. Now, just mark that in so we don't forget. Our x-intercept, this time, when we're working out our x-intercept, we'll make y nothing. So we'll say nothing is x plus 1 cubed plus 64. We need a good way of solving for x here. So what we'll do is we'll take 64 from both sides first. I'd like to get rid of that cubed, so I'll take the cubic root of both sides, which will leave me with 4. Should have made that a minus, shouldn't I? And then I will take 1 from both sides, so I'll end up with minus 5 being x. And so when x is minus 5, y will be nothing. That will give me my x-intercept. And then I just need to draw it in. It'll come up, inflect, and carry on up this way. In the second example, or in the first example really, and the reason why I did that one first is that it may not be clear how I get the point of inflection from here. I'm getting the point of inflection when I look at that as being 0, 27, but it would be fair to ask how I got that. And so perhaps if I write this equation out slightly differently and make it might make it a little clearer, because the equation that I've rewritten tidied up makes the original equation, and there you can see that you've got an x value of 0 and a y value of 27. So that's where that comes from. And then we go about finding out our y-intercept and our x-intercepts the same way. So we can say, oh, and I forgot in the first question that my dominant term, of course, was x cubed. In this one, it will also be x cubed, but this is a negative x cubed. Okay, so let's go back to the y-intercept. Oh, might change to the right color. Let's go back to the y-intercept. What we're doing is we're making x 0 in order to find out y. So y will be 27 minus nothing cubed. So y will be 27, and pop that in. And then what we want to do to find the x-intercept is we're going to make y nothing. So we say if y is nothing, what's x going to be? This time I might add x cubed to both sides to make everything positive. So I'll have x cubed equals 27. And then I will cubic root both sides, and I'll find that x is 3. And I can pop that in. And now all I need to do is plot it. So I've got a y-intercept somewhere about here, 27. I've got an x-intercept here at 3. And I've got a point of inflection which happens to be on my y-intercept, which is 0, 27 as well. Now, the other thing to note here is this dominant term is negative. So my curve's going to go the other way. So this time it'll come down through 27 and inflect and carry on down through 3. And that's what that graph will look like. We got one more. This one is in a nice format for us to work out what the point of inflection is. So straight away we can see that it's going to be 4, 3. Again, I'm getting that from this and this. My y-intercept, so when x is nothing, will y be? So if we're working out the y-intercept, y will be 3 times nothing minus 4 cubed plus 3. So y will be 3 times 4 cubed, which is 64, plus 3. Y will be negative 189. Big numbers this time. My x-intercept, I'll find out by making y nothing. So this time I'll say, righto, nothing equals 3 times x minus 4 cubed plus 3. Start rearranging this. So righto, I'll take 3 from both sides. So I'll end up with 3 over here, minus 3 rather. 3x minus 4 cubed. Let's get rid of this 3 here next. It says to times, so of course we'll divide. So we'll end up with minus 1. This time we will cubic root to get rid of this cube here. So we'll end up with minus 1 again, because minus 1 cubed is going to be minus 1. And over here we've got x minus 4. Let's get rid of the 4. So we'll have 3. So a little bit more involved, but still quite achievable. The dominant term this time will be 3x cubed. Okay, so that gets taken from this, because if we expanded this, we'd have to then multiply it by 3, so it'll be 3x cubed. And now we'll just plot it. So what have we got? We've got a huge y-intercept that's way down here somewhere. Might change color just in case it crashes into the working out that I did. So this is down here at minus 189. And then I've got an x-intercept up here at 3. I've got a point of inflection at 4, 3. So it's going to happen above the line. And so what we'll have is we'll have a curve that is rising, inflecting, and then rising again. And we're done. One thing I have neglected to do the whole way through this, which you should definitely do, is make sure that you are labeling your X and Y axes. Okay, so go back and make sure that you've got all those labeled. We don't want to throw away any marks.